Hi guys, welcome back. This is Shrikant. Today in this video we'll be talking about one of the tips while working on the performance tuning. So in this tip we'll be talking about the removing the correlated subquery. Try to minimize the use of the correlated subquery. And first of all I will like to talk about how correlated subquery will impact the performance. Correlated subquery, yes. So basically, first of all, we should understand what is correlated subquery. A subquery which is depend on the main query. So the condition in the condition part, that condition will be based on the output of the main query, right? So that is a correlation between the child query with the parent query. Okay, so the first of all, when we'll go with the correlated subquery, that time what happen? That time the row by row operation will be happen. So as we know, when there is the row by row operation, so there will definitely performance issue, because as row by row means one by one we will perform some operation, we'll do some calculation, so definitely it will take time. It's always beneficial to perform the set based operation. Okay, now in these tips I will be talking about how correlated subquery can be replaced to another way so that we can get the performance gain. And how we will get performance gain, we'll talk about that. Let's talk about, we have one table called as the a general table called as the people. Another table we are having, and that table is a company table. People table are having column like ID, general ID, name, general identity, then company ID, in which company they are working, then the name of the employee. These are the three columns we have in the people table. Next table is company table. In this one we are having the company ID as the primary key, then name of the company, right? So let's convert it into table. Where can int name of the company, then create table, great. Next, create table company, now we have written the script for creating the two table. In my database I already have this table, just drop it. Now we have created script for creating this two table. Now let's have then we will insert some data in it. Insert data in this two table. We'll insert some data in it, right? So before that we can do one thing. We can create one sequence object to have this sequence number auto increment, or we can simply create some identity column. Okay, now insert some data in these two tables, people, we are having three column, but one is identity, so we only need to pass two column. For employee table, then we'll write some instead statement. Company ID is id plus 1. We'll do some only random data, and employee name is Shrikant. Okay, go. Let's insert some 1000 rows in it. Some random number I'm just trying to add. Let's run it. When I execute this query, 1000 row will be 1000 employee will be added. So here, okay, so here issue is, first of all we need to create this table. Okay, great. Then we haven't created a table and we were trying to insert the data. Now let's run the query. Now 1000 rows will be added. Let's query the table and see the output, how many rows we have and how the data looks like. When I execute this select query, I can see different timestamps there, okay, but they haven't changed. Okay, let it be. So my intention is to show you that these are the different employees I have, and these are some company IDs, and these are the name of the company. You can ignore the exact name, just try to understand the ID only. Okay, I have another table called as the company table. Here I'm going to insert some data in it. Let's talk about it. The name of the table is company table. Here I have the two column called as a company ID and the name of the company. So name of the company I need to pass, because other column is identity column. So let's pass it. I'm passing it as the XYZ. So XYZ is my company name. Let's insert it, which is having the ID is equal to 1. When I query this to table parallelly, what will I see? When I query this table, let's see what will we see. I will see there are 1000 records in the first table and there is only a single record in a company table. Okay, now what my intention is to show you, what my intention is to demonstrate it here is that if I want to see the name of a company in an employee data, how I can see it. For that I need to write a query in such a way that I will have the data. So I need to see all the employees, and what I need to see, I want to see the name of the company. So I don't have the name of the company here, so I need to write some correlated subquery. Here I am writing P1. Then here the things come into the mind, what should I write? I should write here the correlated subquery. I will show you here from company, because I only require the company where this is the C1, where C1 dot company ID is equal to P1 dot company ID, right? So what does it mean? It means that I am querying the data of a child table based on the parent table. What I need only company name, C1 dot company name of the company, right? So what I am trying to do, try to understand this query. You will see here different thing. The first thing you will see there, I have written a subquery here, which is pulling data from company table, and the condition is based on the parent query, right? Let's run it and see the output. When I execute this query, I will see the data in a tabular format, and then I will see one new column has been added with this table, and that table is having the string data. Okay, so in this case what happened, let's try to understand the execution plan. Let's see the execution plan also. Okay, when I see the execution plan, what will I see? I see there is a table scan, that's fine. Then aggregation, then table scan again happen on P1. Table scan happen on the P1, then you can see table scan will also happen on the C1 because we don't have indexes on that. Then the join happened, then the scalar, and then this thing happened. Right now, one thing very important here, that I have an employee table, I have people table. In the people table I have near about 1000 row. So for 1000 row, every time this table queried for 1000 rows, 1000 times this condition will be satisfied, and so 1000 times the data will be pulled from this table. So 1000 times there will be hit. So this is the wrong case basically. So maybe in future, if we have a 1 billion record and we are querying a 1 billion record like this, so definitely there will be a big performance issue. So to avoid this, we need to think about a different solution. We need to go with the left join. So how left join will work, I will try to show you how. First of all, I will write a query in such a way so we can understand how really it will be beneficial or not. So I want the all people data, but I only need to have the name of a company because I don't have the name of a company in my people table. So how would I do that? I will simply join with the company table C1 on P1 dot, this should be company ID is equal to C1 dot company ID. Right. So you may have a question that why I use left join, why I not use inner join or out any other outer join, why left join? So left join is very important here, because sometimes what happen, we may have the people data, but due to some data issue, or the issue due to some issue which is done by other people, mistakenly they have deleted some data from the company table, so that people will not be coming to the result set. So to avoid those situation, I want to see all those people still don't have any company belonging to them, then I need to go with the left or join. So I simply need to do what? I simply need to do P here, take all the columns of the people table, then C1 dot company, name of the company. So what happened? So how I can prove that this query will give me a faster performance rather than the old one, right? Because when I am doing a join, so only a one time only data will be put. You can see here only one time data has been fetched, and then the query has joined the data and we got the result. So only one time data pulling this in this one, or in this time in this query, basically number of rows, number of time it was being pulled. So this is really a tricky trick for performance tuning, for avoiding the performance issue. So we should always try to write a query with a join rather than using the correlated subquery. I hope you like this video, and thanks for watching. Have a great day.